This tutorial is on Chapter 26, Length Contraction. Here are some important points on length contraction. First, the measured distance between 2 points depends on the frame of reference of the observer, so it basically depends on who's looking. Second, the proper length, or L sub p, of an object is the length of the object as measured by someone at rest relative to the object. So the proper length is the length measured by a person who is actually at rest with respect to the object. Also, the length of the object measured in a reference frame that is moving with respect to the object is always less than the proper length, and this effect is known as length contraction. So again, the length is always less than compared to the proper length, or the length that is observed by a person who is moving with respect to the object is always less compared to the proper length, or the length as measured by someone who is at rest with respect to the object. So here is the equation for length contraction. L is equal to the proper length LP multiplied by 1 minus the square root of V squared minus C squared, and the length contraction takes place only along the direction of motion. So here is a figure. Observer O at rest with respect to the meter stick measures the length of this meter stick as 1 meter. However, to an observer that is moving with respect to the meter stick, he is going to measure this meter stick shorter than a factor of the square root of 1 minus V squared over C squared. Again, this is for that reason that L is always less than the proper length, and therefore we call it length contraction. One of the challenges in solving problems related to length contraction is the identification of the length proper and the contracted length. So just remember that the length proper is the length or distance as measured by someone who is stationary, whereas the L is actually the distance that is measured by someone who is moving with respect to the object. So again, LP, or the length proper, is measured by someone who is at rest with respect to the object. Let's look into this problem. An observer on Earth sees a spaceship at an altitude of 4,350 moving downward toward the Earth with a speed of 0.970 c. What is the distance from the spaceship to Earth as measured by the spaceship's captain? Now, to the captain, the Earth is rushing towards her ship at 0.970 c, and hence the distance between ship and Earth is contracted. So therefore, the L that is measured by the captain is the contracted length, and the L proper, or the length proper, is 4,350, as this is the distance of the spaceship and the Earth as measured by someone who is stationary on the Earth, not moving with respect to the Earth. So therefore, this should be our LP. So very simply, we could just substitute our given to the equation. L is equal to LP is multiplied by the factor of 1, or the square root of 1 minus V squared over C squared, and this is equal to 4350 kilometers multiplied by 1 minus V squared is 0.970 c squared divided by C squared, and then we will have 4350 kilometers multiplied by 1 minus 0.970 squared, since we would be able to cancel the C squared here and that, and this would give us approximately 1.06 times 10 to the power of 3 kilometers, and this is the length, or the distance between the Earth and the spaceship as measured by the spaceship's captain. Now let's move on to part B. After firing his engines, the captain measures her ship's altitude as 267 kilometers, whereas the observer on Earth measures it to be 625 kilometers. What is the speed of the spaceship at this instant? Remember that L, or the contracted length, is always less than the length proper. Therefore, of these two distances, L would be equal to 267 kilometers, whereas the proper length, or the length as measured by someone who is stationary with respect to the object, in this case the Earth, would be our length proper, or LP, that is 625 kilometers. Alright, and we are asked to solve for the speed of the spaceship at this instant. Then we just have to substitute these givens into our equation, which is L is equal to the length proper multiplied by the square root of 1 minus v squared over c squared. So let's substitute our values. L is 267 kilometers. Our LP, or the length proper, is 625 kilometers multiplied by 1 minus v squared over c squared. Now we could manipulate this equation to solve for v, and v should be expressed as in terms of c. So doing that, we will have v is equal to 0.904 c. And we have solved this equation. Or by the way, you may also express that in a proper number, wherein you would really multiply this answer with the speed of light, which is 3 times 10 to the power of 8 meters per second, and that would give us let me just take that down. That's about 271 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8 to the power of 8 meters per second. So both answers would be acceptable. However, if the question specifically tells you to express the velocity in terms of c, then this should be the correct answer. And that concludes this tutorial on length contraction. Once again, always remember, physics is easy with Mr. Jesse.